First learned probability like 6th grade, 5th grade, rolling a dice, picking a card. Yeah, like right elementary school, don't we? Okay. So you just got to know the words that go with this. An outcome is the result of a single trial or probability experiment. Of a single trial or probability experiment. You call that your outcome, okay? Your sample space would be putting all those outcomes together. So again, if I flip a coin, my outcome could be heads, my outcome could be tails. My sample space would be heads, tails, okay? It would be all the outcomes, the set of all possible outcomes. That's terrible. Of a probability experiment. So again, just to give you a few common examples, if you toss one coin, your sample space is written in this like weird bracket notation here. And so you'd write, you know, heads, tails. That would be your sample space, all the possible outcomes. Rolling one die. Didn't know if you know that. A dice, when you call a single dice, you don't call it a dice, you call it a die. Rolling one die. What's your outcomes on a dice? 1, 2, 3, 4, 5, 6. Okay. Hopefully you don't have any weird looking dice here. Deck of cards. Now I hate to tell you this. There is a lot of deck of cards questions. So if you are not familiar with cards, we're going to kind of talk about that real quick. Do you know how many cards there are in a deck? There are 52. Okay. I'm not going to write them all out, but there's 52 cards. Just so you know, for a deck of cards, that you have two different colors in the deck of cards. You have the red suite and suit, and then the black. You have how many face cards? Do you know?
Jack, Queen, King.
Jack, Queen, King. Ace is not a face card. So Jack, Queen, and King. So it'd be 12, okay? So you've got to know this. And then you have hearts, which are red, diamonds, red, spades, black, and clubs, black, okay? Sorry, I got to. And out of each one of those, do you know how many are in each one of those? Like how many hearts there are total?
There's Ace,
3,
4, 5, 6, 7, 8.
All the way up to 10. Jack, Queen,
King.
13. 13 divided by 4. 13 times 4 is 52. Okay. So I'm just letting you all know that. Hate to tell you, for those of you who are like, I don't know my cards at all, you'll be doing so many of them that it'll just happen. Okay. You gamble all the time. Yeah.
Oh, I know.
Okay. Now I want to talk about the sample space for rolling 2 dice. And I do want you to write this down. This is going to help you with one of the questions in your homework. It's going to seem annoying, but it will definitely help you. You could end up rolling a 1 and then a 1. Agreed?
Yeah.
Or what?
2 and 2.
Okay. I was going to go with 1 and 2. I like to keep with pattern, but yes. 1, 3, 1, 4, 1, 5, 1, 6. Would you all agree? Okay. But you could roll a 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Whoops. I want you to keep going. There's a reason why. Okay. 3, 1, 4, 1. However you want to do this, but you are going to want to do it because you're going to have to find a sum, the probability of getting a sum. So if you actually have this in your notes, you could easily look to see the sum. 3, 2, 3, 3. How many? 36. 36 possible outcomes. So when we start to do probability out of rolling 2 dice, you would have 36. Now, how's another way of getting that? One dice has 6 choices. The second dice has 6 choices. When we start to do more probability, what you do is 6 times 6. What if I threw a third dice in there? Do you know what the outcomes would be there? 6 times 6 times 6. 6 to the third power. That's how many choices of dice you can get. Okay, so it gets to be quite a bit. And what'll happen is you want to then, if I ask you questions like, all right, well, what's the chance of you getting a probability of a sum of 7? Okay, sum of 7. So you'd go through here and you'd be like, okay, well, 6 and 1 makes 7. 5 and 2 makes 7. And you just start adding up all the 7s. And you'd say, okay, there's 1, 2, 3, 4, 5, 6 out of how many? 36 possible sums. Same thing with getting a 7 or getting a 10, and you just go through and you add. So this is going to help you out for some of the things we do. Later on, we won't have to do it. We'll have other ways of getting around it. When you hear the word event consists of a set of outcomes of a probability experiment of a so sometimes they refer to like an event being like drawing a king. Drawing a king would be an event. All right. And then they're going to talk to you about this thing of equally likely events. You want your events to be equally likely. You don't want to flip a coin and it have 2 heads on it and then say, hey, what's your chance of getting tails? That's not an equally likely event, okay? That's not good, probability-wise. So if you have an equally likely event, you want events that have the same chance of occurring. Now, we won't get into the political discussion of what's going on because that would be bad, and Mrs. Seta would have to. I'll give it to you in a minute. The way that we write probabilities, we put a capital P, which you saw in the other homework, and then you name the event after it. Okay, so you would say a probability of rolling 1, probability of drawing a king, probability of, whatever, the chance of being rain or whatever, okay? And what you do is you're saying it's the number of outcomes for that event divided by the total number of outcomes in the sample space. You want your probability of the event to always be a decimal, a fraction, or a percent, okay? A decimal, a fraction, or a percent. And I want to draw for you what's called the line of probability of your chance of happening for any event, for anything, okay? Probability can only be between 0 and what? 1. Or a 0% of it happening, which means it is impossible. There is no way, Jose, that this event will happen, as opposed to 1, which is 100%, which is what? Certainly happening. Okay? Obviously, in the middle is what? A half or 50%, which means you're just equal chance of it happening, okay? So this is why Mrs. Seta does not gamble. And I know you're all gonna laugh at me as you normally do, okay? But your chance of winning the lottery, precious ones, if you look at the back of the card, of the lottery card, they actually have to give you the odds of winning. Your odds of winning are here. Like, I wouldn't even say here, I'd actually say probably closer to there. But this is the same people that are like, hey guys, there's a 20% chance of rain outside. Are you gonna bring an umbrella? You're like, no, it's only 20%. But yet you're like, I'm buying all the lottery tickets because if I buy 20 of them, somehow I'll magically win. You're not going to, okay? Sorry, hate to tell you. But there's that one guy that go there. It has to be 100% or 1 whole and under. So make sure all your answers are fractions and they're always under 1 or they're under 100%. But this is why I do not gamble. I'm sorry. I don't know why y'all.
Oh, good.
Find the probability of getting a black 6 when a card is drawn from a deck. Okay. So again, for those of you who don't know deck of cards, do you know how many black 6s there are in the cards? There's 2. So the way you write it is the probability of getting a black 6, that's your event right there. And you'd say, okay, there's 2 out of, what are the total cards in the deck? 52, which is 1 out of 26, which is a 0.038 or 3.8% chance, y'all. And you're going to bet on that right there.
Why are you getting so worried about
Because do you know how many people have problems with gambling?
me?
You got gambling because you think, oh, 3.8, I'm totally going to get it. Or you don't even put it into perspective.
Oh,
And it shocks me because the same people that I say that to, I'm like, there's a 10% chance of rain. You're like, I'm not going to bring my umbrella. But you're like, there's a 10% chance of you picking a black 6 or something like that. You'd be like, I'm picking it. I'm putting all my money down on black 6. Okay. The complement of an event, we talked about that before also, is the set of outcomes in a sample space that are not included in the outcomes of the event. And the way that we write this, we saw on the homework, is you would put that little prime right next to it. Okay, so if I said, what's the probability of not picking a black 6? Not picking a black 6. If the probability of picking a black 6 was 2 out of 52, what about not picking a black 6? What would that be? 50 out of 52. It's all the not black 6 cards. Okay, so now that one you'd all probably bet on.
no, I don't gamble.
That's right. Thank you. That's right. Yes, I'm sorry, honey. So we're going to finish this off by just doing find a complement and then find a probability, and then that'll be the end of today's lesson, which you have homework on this, but like I said, the next lesson you won't have homework on. So I would like you to find the complement because you'll have to do this for homework. Luke, you got that written down or no? Almost. Begins with S. Find the complement, okay? So if my probability, if I'm saying selecting a day of the week that begins with S, then my probability, the complement would be not beginning with S, right? How many days of the week do not begin with S? 5 out of how many? 7. That would be the complement of that event. Okay. Let me do one more, just an easy one. And like I said, homework tonight should be like this, should be easy. Find the complement of selecting an even number on the die. That's a usually common one that they do. Well, my probability for the complement would be not picking even, which means you are what? Odd. So how many odd numbers are there on the die? 3 out of, or a half, or 50%. Again, however you write it tonight, I'm fine with it. Just make sure you write it. All right, and then last thing I'm going to give you, they're going to give you a table. I actually think this is one of your homework problems. I got to find out which one. This is your blood type. And this is the frequency of it occurring. Type A, type B, type AB, and type O. Do you know which one is universal?
No.
Do you know the AB? Okay. So we'll talk about these all and then we'll be done. First things first, when they give you a frequency table, I want you to be careful here. You need to total something up, right? Haven't we always done that when we did the frequency tables? Why do we have to total up? Because we have a total amount of, right now we have 22 people with A, 5 with B, 2 with AB, 21 with type O. So that means we have a total of 50. And that's what we're going to do all of our probabilities out of, is the total 50, okay? So A is really easy. What is your chance of having a type O out of this group right here? Your chance of having type O is what? 21 out of 50. Easy. Look at this word right here. What's your chance of having type A or, there's that or, type B? What do you do with type A and B? What do you do there? You combine them. You add them. Combine. Or means combine. Remember, or is the U. So what would that be?
27.
Out of 50. What's your chance of neither having type A nor type B? Neither having type A nor type B. Where'd you get 23 from?
Adding A,
A,
B,
B,
and
and
AB doesn't mean you have an A or a B. It just means that's your blood type. It's AB. So yes, this would not be an A or a B. This would not be an A or B. So that would be 23 out of 50. All right, last one. Picking a person who does not have AB. Two of them have AB, so that out of the 50, that means how many don't have AB?
48.
Out of 50. You can reduce it if you want to. You can leave it just like that, 24 out of 25. Okay, so homework tonight, which you can start right now, and then I'm going to do notes on the next lesson in a few minutes. Not Ray.
Why are you doing so much this week?
Because we're behind. Well, I don't want to say we're behind. We get ahead, then we go behind. Then we get ahead. It's.
Well, we barely get any.
Yeah, I know. Why-
I just was gonna say it's our B days schedule. I never see you all, so I'm like, oh, we were ahead. Oh, now we're behind. Oh, we have a double A week. Oh, now we're behind. Yeah, it's just.